In this video, we will take a look at integration by parts and some examples where integration by parts can be applied. Integration by parts might be the most difficult integration technique in your syllabus, but I'm going to show you 3 easy steps on how to perform this technique. Firstly, let's take a look at the process of integration by parts. It is basically derived based on the reverse of product rule which we have learned in differentiation. Looking at this product rule formula, if I rewrite it by bringing the v du dx term across to the other side, I will end up with this equation. Thereafter, if I integrate this equation throughout, I will end up with this integral equation, which is actually the formula for integration by parts. This formula might look complicated, but this technique is actually not too hard to grasp, as I will show you later on. Integration by parts can easily be completed in 3 steps. The first is to determine 2 terms, one term to differentiate and one term to integrate. This can usually be done using the LIATE rule, where L stands for the log term, such as your ln, I stands for inverse trigo, such as tangent inverse x, cos inverse x, or sine inverse x. And A stands for algebra, and all polynomial terms are algebraic terms. For example, you have x, x squared, or even just a constant c. T stands for trigo, such as your sine x, cosine x. And E stands for exponential, e to the power of x. The rationale behind using this LIATE rule is that as we move down the list, the first term that we encounter will be the term that we differentiate, and the other term will be the term that we integrate. Next, we follow a standard template to write the integral as such, a square bracket followed by an integration. What we will do is, in this square bracket, I am going to do only integration. That means the term which I have selected to be integrated, I will integrate it, and the term which I have chosen to be differentiated, I will not touch it at all. Whereas in this second term over here, I need to do both changes, both differentiation as well as integration. So the term which I have chosen to integrate, I will integrate it, and the term which I have chosen to differentiate, I will differentiate it. And finally, once we have filled in the blanks in the second step, we can simplify the terms and solve it very easily. Now let's do a quick example using x e to the power of 2x. So if we apply the LIATE rule, x is an algebraic term over here, and e to the power of 2x is an exponential term. And therefore, using this LIATE rule where we move down the list, we can see that x is the term that we are going to differentiate, and e to the power of 2x is the term we want to integrate. And therefore, let's move on to the second step. This is equals to a square bracket minus an integration. And in this square bracket, we are going to do only integration. That means for the x term, I'm going to keep it. And for the e to the power of 2x term, I'm going to integrate it, which gives me half e 2x. Now in the second term over here, I'm going to do both changes. That means for x, I'm going to differentiate it to give me a 1. And e to the power of 2x, I'm going to integrate it to get half e 2x. Now in the first bracket, there is nothing much we can do. It is just this term. But in the second expression, we will still have to perform another integration. But now this term over here is very easy for us to integrate. It is just a simple exponential term. And therefore, we can solve this integral to become half x e to the power of 2x minus 1/4 e to the power of 2x plus c. Let us take a look at some examples now to help us better understand the concept of integration by parts. So in this first example, we have to integrate the term x cubed multiplied by ln x. So let's apply the first step of LIATE. Here we have x cubed term, which is an algebraic term. And we have a ln x, which is the log term. Therefore, we know that we are going to integrate the x cubed term and differentiate the ln x term. Let's move on to step 2. our standard template, a square bracket minus an integration. And in the square bracket, remember that we are only going to perform integration. So I'm going to change the x cubed into 1/4 x power 4, and I'm going to keep ln x constant. Now in the second term over here, I'm going to do both changes. Therefore, x cubed becomes 1/4 x power 4, and ln x, I'm going to differentiate it to get 1 over x. Now let's simplify and solve this equation. In the first term, there's nothing much I can do. I'll just keep it 1/4 x power 4 ln x. And in the second term, it is integration of 1/4 x cubed, which we can again integrate very easily to give us this as the final answer. Although I've mentioned earlier that for integration by parts, we need two terms, we can still use integration by parts to integrate a single term. For example, tangent inverse x. This can be done by rewriting the single term as a multiple of two terms, 1 and itself. And using our LIATE rule, we are going to integrate the 1 and differentiate the tangent inverse x. This gives us, in the square bracket, x multiplied by tangent inverse x, and in the integral, x multiplied by 1 over 1 plus x squared. And let's simplify this term slightly. We get x tangent inverse x minus integration of x over 1 plus x squared dx. And to integrate this second term over here, we can simply multiply by a 2 on top and a half outside to balance it. And this gives us the familiar form of f prime x over fx, which we have learned in integration 1. And therefore, this can be solved easily to become x tangent inverse x minus half ln 1 plus x squared plus c. Sometimes we have to perform integration by parts twice in order to solve an integration. For example, in this example over here. Now let's first determine the term to differentiate and integrate. X squared will be the term that we differentiate, and e to the power of 2x will be the term we integrate. And therefore, we will end up with our standard template, a square bracket minus an integration, and in the square bracket we have x squared, we get a 2x and e to the power of 2x. Whereas in this other term over here, I will have 2x multiplied by half e 2x, which cannot be solved easily, but let's simplify it first nevertheless. Okay, so now we end up with this term over here, which we have to perform integration by parts one more time. And therefore, this gives us a 2x e to the power of 2x minus, I'm going to use a big curly bracket to represent this integral over here. And thereafter, my square bracket and my integration for integration by parts. In the square bracket, I am going to integrate e to the power of 2x and keep x constant. So x times half e 2x minus integration of 1 multiplied by half e 2x. And therefore, we can simplify and solve everything to give us 2x e to the power of 2x minus half x e to the power of 2x plus 1/4 e to the power of 2x plus c. Finally, this is a very special case which you have to remember the trick in order to solve. Whenever you have an exponential term multiplied by a trigonometric term, you have to use this special trick in order to solve the integral. Let's try to solve it now. E to the power of x is the term we integrate, sin x we differentiate, and this leaves us with ex times sin x minus integration of ex times cosine x, which cannot be integrated easily. We have to perform integration by parts one more time on this second term over here. And let's perform another integration by parts. So we have ex sin x minus a big curly bracket, a square bracket of ex times cosine x minus integration of ex times negative sin x dx. Let's simplify this expression first and see what happens. We will get ex sin x minus ex cos x minus integration of e to the power of x sin x dx. Now, you observe that this term is exactly the same as our question. So we have performed integration by parts twice, but we still do not end up with anything new. So what we can do now is to simply bring this term over to the left hand side. And therefore, we will end up with 2 integration of ex sin x dx equals to e to the power of x sin x minus e to the power of x cosine x, and therefore integration of e to the power of x sin x dx equals to half ex sin x minus ex cos x plus c. So this is the special trick in this question that you have to do to bring your term on the right hand side over to the left hand side to combine with the original question in order to solve it.